Okay, so here we're going to talk about how to display our data graphically. So far, we just talked about the dot plot. Dot plot is lovely. It gives a very good representation, but there are other ways to display our data. So we're going to talk about stem plots, also known as a stem and leaf plot. You might have done that in like middle school. And then we're going to talk about histograms, and we will discuss how to use our graphing calculators for those purposes. So in example 5, it says who is taller, and we have the data that has 14-year-olds from United Kingdom that were randomly selected in a census, and our heights are in centimeters because centimeters make sense, unlike inches and feet. So we have males and females. So all we're gonna do right now is just create stem and leaf plots and talk about how to do this and all of the aspects that you have to include in your stem and leaf plot. So let's remember how to create a stem and leaf plot. So for the stem and leaf plot, we're gonna have a stem that you need to choose, and the stem is, well, how to describe it? Well, let me just do this, and that would be fairly obvious. So for the stem, we're picking the core number. So for example, if I'm displaying 154, okay, then I will write down 15 right here. So that represents 150. And then I'm gonna just include the leaves will be all of the values that the units in this case. So I'm going to use 4, so that means 154, and I will also cross this out. Then I will look at the next number, which is 157, so I will put 7 here, cross it out. Now it has to be done in order. That's very important. All of this has to be done in order. I did not order this data, so then we have to continue looking for other data with 150, and actually we can see that I missed one. I'm very sorry about this. We have 151, so I actually need to adjust this, and I have to put 1 there first, then I have to put 4, and only then 7, and then I have another one which is 159, and I will cross this one out so we know that this is done. Okay, so these are all of my leaves, or all of my data that start with 150. Then I will go on to 160. So I'll put 16, that represents 160, and I'm gonna start looking for those values. So we have 162. So that means I'll just put 2 right here, and I will cross it out. Then we have 163. 163 right here. So I'll put 3 underneath it, cross it out, and so on. So I'll just create the stem and leaf plot right now by myself, so you don't have to watch me cross out all of the numbers, and then we'll continue. Okay, so here we have our stem and leaf plot. I will write at the top that this is for males, okay? And whenever you create the stem and leaf plot, you always have to include the key. Very important. Don't forget the key that actually shows what does this stem and leaf plot represent, because for the person who doesn't know, it could be 15.1, or it could be 151,000, who knows? So you have to write down the key somewhere on the side, and our key will be 15, and 1 represents 151. So we know exactly what it does. Once again, this is one of those details that students miss, and that is worth points. So be very careful about that. Then I want to create a stem and leaf plot for females also, and I might want to do it back to back so I can compare the two distributions. So what I can do is I just will draw another line here, and now on the other side I will create a distribution for females, or for female children in the United Kingdom. So let's see what we have. So we're starting with 15, which is 150. And if we go down the line or down our data, we have 152. So we'll put 2 right here, cross it out. Then we have 153. Then we have another 153. But we notice that if your numbers repeat, you continue writing them out. Then 157. And so on. So I will fill out the rest here in a second. Okay, so we have our data for the females. Okay, and now by looking at those two, you can compare them. You might want to like mentally turn it one way, so you representing it in a correct order. Also think of which way you're going to turn it, so you're starting from the lower number to the higher. So for example, if your distribution is skewed, so you know which way it is skewed, so be very careful about that. So keep in mind, like for the males, I would turn it to the clockwise, no, I don't know, flip it around clockwise. So think of it as 15 would be in the beginning and then 18 would be at the end. So if it is skewed, you can see which way it is skewed once again. Now we can also notice that for the female distribution, it is not very good representation because there are so many numbers that are only in 150 and 160 centimeters. Okay, so it's not very good visual distribution. So whenever that happens, what we can do, we can break it up a little bit more and create what's called a split stem. Okay, so let me show this in the example for female distribution. So we can do a split stem. So for the split stem, what I will do is the following. My stem will be 15 and then 15, and I'll explain what it means in a second, then 16 and again 16. Okay, and I'm not going to do 17 and 18 because there are no females here that are over 170 or 180 centimeters tall. So what that means that my first one, 15, is 150 to 154, and my second 15 represents 155 to 159. Same thing with 16, that means it's 160 to 164, and then 165 to 169. And that will break up this long list a little bit better. So therefore, by the way, the stuff in green, you don't need to write this in the split stem. I'm just doing it for you. So yeah, you don't need to clarify that necessarily. So therefore, our first line will be 15, and then we have leaves at 2, 3, and 3, and then I'm skipping to the next one, which would be 7, 8, 8, and 9. And for 160, we'll have 0, 0, 1, 3, 4, and then I'm skipping to 5, 5, 6, 6, 7, 8, 9, 9. So this is clearly a nicer looking distribution than what we had earlier. Okay, I'm not going to do the same thing for the males because we get the idea here. Now, if we want to compare the distributions, once again, we're talking about spread, center, outliers, and shape. So I will let you think of how to compare those two, but otherwise we will move on. So by yourself, think mentally to yourself, what is the comparison here? Otherwise we will move on. Okay, so the last thing that we're going to do is how to display the data using histograms. And histograms is actually what we're going to use most of the time, and we're going to use a calculator to do that. We don't need to do this by hand. So knowing how to navigate your calculator is very important. So I'm gonna have the steps written out here for you, and I will show you how to do all of that in a calculator as well. So in the table represents the average points scored, points per game for 30 NBA teams in the season 2012 to 2013, regular season. And we're gonna make a graphing calculator to make a frequency and relative frequency histograms. So remember, by frequency, we mean actual raw points. By relative frequency, so this is just points, relative frequencies means percent. Okay, so we'll discuss how that can be done. So we have all of this data right here that we will need to enter into our calculator. So let me get my calculator started and I'll show you how to do that. Okay, so in order to just enter the data, we're going to enter them in what's called the lists. So to do this, I have the first thing here. So to enter data, we're going to press stats. So pressing stat button, then go to edit. That's number 1 there, and press enter, and then go to L1. That's at the very top. So unfortunately, I cannot point it to you, but at the top you'll see L1. And now here we're just going to enter our data. So we're going to enter 98. You can put 0.0, but you don't have to, since it's the same thing as 98. Then we have 96.5, enter, then 96.9, enter, and so on. So we're going to enter all of this data into L1, into our list 1. So I would highly suggest that you practice with your graphing calculator along with me. Right now I'm going to pause the video and enter all of the data. Okay, so I've entered all the data. So at the bottom, you can see how many data points you included. So make sure that when you included them, you have 30 pieces of data there. Remember, we're talking about 30 teams. This is one of the most infuriating part of statistics, is entering all of the data. In this case, it's quite a bit. On the tests and such, I tend to not give you such big lists of data, so because it is time consuming and fairly annoying to do. So, but we entered all of the data. Now, what can we do with it? Few other things that we can do in a calculator. Well, first of all, we can organize it. We can organize it so it is going to be all in order. Right now, it is not in order, and the order will be important for us sometimes in the future. So, what can I do? I can press second. So that's a blue button. Press second, and then press stats, which once you press second, it becomes a different function called list, but the big button is called stat. So we're looking for stat. It's look for the green alpha button, and it's one button over from there. Then we are going to choose ops, operations, and we're gonna go to sort A. So that's the very first thing there. Sort A, and then enter L1. So to enter L1, you have to press second again, and then find in the numbers, you will find L1. So you press second, the blue button that says second, and then you press 1 on a calculator that turns it into L1. Close the parenthesis and press enter. It just says done. Now, if you go back to your list, and remember to go back to your list, you go to stat and just edit, press enter, you will see that all of your data is in order now. So it's nicely ordered, and it could be helpful for us. Now, here's the main thing, how to create a histogram. So to create a histogram, we're going to press second again, the blue button, and press at the very top y equals. So once you press second, the blue functions are the ones that are actually included there, but we're pressing y equals, and we have different menu for different stats plots. So we're just gonna press enter on one, and we're gonna first of all turn it on, press enter to turn it on, and then we're going down, and we have to pick the type of a plot. So we're going to discuss most of the plots that we can see there, but right now we're concerned about histograms, which is this the one that has a bunch of bars that looks like a bar graph. Okay, so press enter there, and we're going down to X list, and we need to pick which list we're using. Well, everything I've entered is in L1, so we're going to leave L1 there. If you want to change the list like to L3, you just find where it says L3, and oops, that's not what you need to do there. Clear. You press second, and then 3, that will give you list 3, but all of my data is in L1. So I'm gonna clear this and press second L1. Don't worry about this frequency. We're gonna talk about that later. Right now, you don't need to worry about it. So just press enter. And after that, we're going to just press second and quit, okay? And I'm gonna clear the screen. So we just decided on what type of a graph we're gonna create. Now we're going to y equals again. So going to the top, y equals. Now, if it hasn't been highlighted, you have to highlight plot 1. In my case, it is already highlighted because I turned it on. And then I will press graph button. So to the very right, press graph, and nothing happens because you need to change the view of your window. So to change the view, press zoom, and there are different ways, different things you can do, like zoom in, zoom out, and such. We're gonna go all the way to number 9, which says zoom stat. Press enter, and then your calculator automatically creates a histogram for the best viewing. Now, it's not necessarily the best histogram, but it's a histogram for the best viewing. So we can see this histogram right here. Okay. Now, if we trace it, so if you press trace button, it gives us certain criteria there. So it says that my first bar, the width of it is from 93.2 points to 95.35 points. Okay, so if I don't like that, and then it says n equals 10, that means that there are 10 teams